Welcome to my messy workbench. I'm right now in the process of creating a low pass filter for 2 meters. I got some various schematics to build one, and I kind of picked one. This one is from the QRP Labs kind of kit, and I just kind of I just kind of guessed from their how to assemble and the charts, everything on how to build it. So we have there on the circuit we have 3 inductors. Unfortunately, I only have the turns and the diameter. It's 3 turns, all 3 of them on a 6mm diameter. So I can cover that later, but I don't have the Henry ratings on them, so that will be a little bit hard to work with. The good part is I have a spectrum analyzer, so I can see if the filter is working, and I can tune it maybe a little bit on those inductors. On the capacitors, they have them nicely spec'd out. So we have first 22 picofarad capacitor going to ground, then it goes through the first inductor, and then we have 2 capacitor in parallel, a 33 picofarad and a 10 picofarad. So we have 43 picofarads also going to ground. Then we have the third inductor, and then we have the 2 again, the 43 picofarad going to ground, the third inductor, and then going 22 picofarad to ground. So I kind of have it set up in a way that if you look on the left side, on the top left comes in the signal, on the bottom right it would come out. So it goes to the first capacitor, then the inductor, second capacitor is on the bottom, since the inductor lead will be on the bottom, and that goes to ground, then the third inductor, and then we have again the capacitor going to ground, and then the fourth one also going to ground. So I'm here in the middle of soldering things up. I should have one single ground bar right along this line here in the middle, and then on the top and the bottom will be the signal lines. So we see how that works out. So I haven't soldered in the inductors yet. That's what I'm going to do now. On the inductor, how I wound them is I used a 6mm drill bit, and then you just wind them around the 6mm drill bit like this, and you have the inductor. The adjustment I have to do once I have a spectrum analyzer on there, and hopefully it won't be too hopefully it won't be too hard. On the inductors, how you wind them does matter. So in the way I set it up, because I want to come out from the bottom here and end up on the top there, and then go from the top to the bottom. So the 2 outside ones are wound a different direction than the center one. That's what I want to mention. So let me go grab some sandpaper so I can sand off the leads and continue soldering the inductors in place. So here's the finished low pass filter for 2 meters. So I soldered in the inductors, and I soldered all these connection to each other. So the long wire here in the center, that is ground. The short wires on the bottom left and the top right, that's the signal. So the signal goes zigzag through the inductors, and also the capacitors go to ground, as mentioned before. One thing about the emerald wire, the sanding to get a contact didn't work, so I just used that little knife right here to scrape it off. That worked much better. So let me go zoom in a little bit more. So the soliders look fairly decent. I didn't cut off the two ends just because I'm not totally sure what connectors I want to hook on to that. So that's gonna be cleaned up if I actually use it. I haven't tested that one out yet, so that's what we are gonna do now. So we have this set up here on the spectrum analyzer, and it does not look like a high pass filter, a low pass filter. We were expecting right here is if you go over to marker 1, that's a 144. So we are expecting 144 all the way to 148 or so in this region. So that's where the two dots are to be passing, and everything below it. So, but we do have dips here, and our two spots here is -6 dB and -5 dB, so that's quite more attenuation than anybody would want. Then we do have here a drop off, so that's pretty nice, but then it goes up, and right up there where we have again a good pass, that is 456 with 0.6 decibel. So that would be basically another 70 centimeter range, and so our harmonic would be not at all attenuated. So that is definitely not what we wanted. We wanted a high flat line here to about here, and then go down, and then have the rest kind of attenuated. So the way things are right now, that is not very useful. So here's the circuit. Again, we have the 22 picofarad to ground, then inductor, then we have a 33 and a 10 picofarad to ground, then the center inductor, and then we have again 33 and 10 picofarad and 22 picofarad to ground right over here. So for the person following along at home, if we take all the capacitance and put them in parallel, that would be about 130 picofarad. So if we go ahead and measure that, so right here we zero it out, and then we connected one on the ground bar and the other one on the signal, and here we get 137.8 picofarad. Again, that could be because our capacitor's tolerances, and also just having this whole circuit there. So I'm not totally sure if the difference there of the 7 picofarad makes a huge difference. I don't have the inductor values totally, but we can check on the inductor as well. So for that, let me go ahead and calibrate that first. One sec. Okay, so I connected it from one side to the other side, and we get 0.234 microhenry. So that's 233 nanohenry. And if you look over here to the chart, so we are measuring across all three inductors right here. The capacitors theoretically shouldn't make any difference here. If we want to go ahead, we can measure each individual one. I kind of have to hold up onto it. So that is the one all the way to the left. So 96 nanohenry. Then let's go ahead and check on the right one. That is 59 nanohenry, so a bit lower. And then for the center one, I don't have points to attach that, so that's gonna be hard. two hands. Hold on. Okay, I could find a spot where I could grab it. So that is right now at 22 or so, depending on how much I wiggle here. Microhenry. Nanohenry. What does that tell us? Fortunately, it doesn't tell me too much. So the one thing is, these are the cheapest capacitors that are available, really. So I'm not sure if they are great for RF. So one of the ideas is to get a little bit better capacitors and try this out again. So one thing with my build I was wondering is about these capacitors. They're pretty much the cheapest capacitors that you can get, and I was wondering if that might be a problem. So I went out and bought some better capacitors. They're still probably not top of the line, but they definitely are better. And see if that did any difference in the circuit. Everything else is pretty much built the same coil inductors built, the same setup, the same value of the capacitors, and also in the back pretty much the same wiring there on it. So let's go check out if there's any difference between that and if that one actually looks more like a low pass filter. So I got everything hooked up, and let's look over at the spectrum analyzer. There I did set the range a little different this time. We are going from 100 megahertz all the way up to 500 megahertz, just to zoom in a little bit. And here's what we are seeing. So we are seeing some blockage right at the beginning. The marker 1 is at 144, and the marker 2 is at 148, and that's pretty much the band where we want to transmit. So we are definitely here attenuated well below 10 dB, and then it jumps up, jumps down, jumps up, and then it kind of fades down there. Not totally sure if I need to change some of the setup there to get that more into the right range or not. Let's hook up the prior circuit and let's compare that. So this is with the better capacitors, and hold on. This here is with the lower quality capacitors. So we see still our frequency range of interest is still down in below 10 dB. Then we jump up a little bit and then we drop down. So both of them seem to be fairly similar. So it's not really the capacitors. Now my question is this here the band pass that I need to tune somehow over there? And that's the attenuation that I get? I mean, I saw there the two dips and then the drop down. The one problem though is with my circuit, I do not have variable capacitors, so I cannot change the capacitance. I can just mess a little bit with the inductor, and I'm not totally sure that makes much of a difference. Let me try playing around with the inductor. Whenever I touch it, it will change everything anyway. So that's a little finicky. So I'm gonna do that off camera and see if I can get that a little bit better. Okay, I decided to let you see a little bit as I change how the values change around it. So this is the board with the cheaper capacitors. Let's go ahead and I need to figure out which one is which. Okay, that's the antenna side. So the inductor on the antenna side, I'm gonna push that apart. So I have my fingers right now on there. So pushing those apart quite drastically. So we did see a little shift there. Now the one at the, sorry, that was not the antenna, that was at the radio side. The antenna side comes now, So yeah, right up there, when I touch it, you really can see there came like a little dip down. So I stretched it apart. Now the center one, let's stretch that apart. Ooh, there on the center one, that was actually kind of nice. So we got that peak up there. If we could get that somehow up. Let's push together the radio side. Oh, that's being pushed quite well together. There, we saw this peak kind of wandering in. That was interesting. I think the key is to hold my hands there. So let's go on the antenna side and push those coils together. Oh, that is actually getting much better there. If you look over here, we got these two peaks there, and now we got a drop. If we could get that up, that would be awesomely exciting. So I'm messing around with the antenna side. I'm really squishing them together now. I can show you later. So that is, wow, that actually kind of gives me hope here on that. So does that mean too much inductance, too little inductance when you push them together? So right now, let me show you here the situation on the setup. So right now we have these, that's the antenna side, that's the transmitter side, totally squished together, and the middle center one I have apart. So let's go ahead and try messing around with the center one and see what we're getting there. So right now it's totally apart. Now I'm gonna go ahead and move it just kind of to the middle, kind of again. That was more like how it was before. Don't really see too much change here. Let's go ahead and squish that more. I'm right now focusing mostly on that, not on these two sections. And yeah, no, I really wonder if it's a capacitance that I need to change on here. Bummer. We got definitely close here on it. If I can move that a little bit over, that would be just, if I put through a drill bit, that's a drill bit through on the antenna side, and over here now on the, I'm not getting it through it at all. Let's push that guy through here. Yeah, not getting it through right now. But that is really interesting. So we got that somewhat close. I could turn that maybe a little bit. Does that help? And that turning that a little bit. Just cannot quite get that last bit out. So the middle inductor doesn't do too much for us. So now at the middle inductor is all totally squished together. Let's tear it apart. Thinking of it, really, if we would get that up higher, then we would have a good drop off. But right now we have like, where can we read the marker? So the marker 2 is at 148 and we have -6 dB, and the marker 1 is at 144 and we have -2.8 dB here. So that's really a bummer. If you would be right over there, that would be perfect. So I really think we could potentially get there, but we have to change capacitance on it. And I don't have variable capacitance. So if I just go ahead and grab a 10 picofarad capacitor, can I hold it somewhere in between it? So let's see, how can I do this here? I'm gonna shake here a little bit, grab something out of the drawer. If need to flip that around. How much does that screw it up? Okay, so if we take this capacitor and put it right here, so now the capacitor is on the side where I have the double capacitor. Now I have a triple capacitor. There's a 10 picofarad, and that's toward the radio side. So right now it's on, and now it's off. So it definitely did move it down a bit. So that looked promising actually. Over here, what did that do? So now I have the, again, the double capacitors, another 10 picofarad capacitor and on it, and that kind of moved up. At the tail side, not so much. How about we grab a 22 picofarad and put that on the top and see what happens then. I mean, ultimately you want to do much more tuning there, and I think my key is I really do need to have variable capacitors in there. I cannot just ooh. How does that look? Ah, that looks pretty. So right now I have a 22 picofarad capacitors on the side where toward the radio, where we have the 2 capacitors. That is, so it was already a 10 picofarad and a 33 picofarad, and we added 22 picofarad to it, and that really looks nice. So now 144 is -0.1 dB, 0.2, whatever. But there we kind of have a bandpass filter, and then kind of a weird crappy looking bandpass filter that we got there. But that looks pretty promising. Let's try to do that with the better circuit. And if that really works out, I might actually go ahead and solder the capacitor in there. So hold on, I'm gonna switch. So now I have my second build there with the slightly better capacitors. And this here is now the coils, just like I showed you before, they aren't squished together. And I'm taking the 22 picofarad capacitor and put them at the same place toward the radio side where we have the two capacitors. And right now it's off, now it's on again. I don't see much change there. Let's go over to the antenna side and hold it there. Right now it's on and now it's off. There's definitely a little movement. What was the movement? The two peaks on the higher frequency side kind of come down. Just go ahead and do some fun here. So directly on the antenna side, the capacitance to 22 picofarad. Sorry, yes, picofarad. Not too much. And how about the radio side here? Hold on. Wiggling, wiggling. Okay, now it's on. And now it's off. Okay, not too much yet. Let's turn the board around and mess around with the inductors again. Man. Everything is pretty sensitive here, huh? Okay, so let's just go crazy here, and on the antenna side I'm gonna squish the inductors together, just totally together there. And now on the radio side I'm squishing the inductor together, and yeah, that definitely brings that one wavy thing up to our band. Wavy thing, I mean to peak. So now what should we do with the center conductor? Inductor. So I'm tearing that apart right now. Not tearing it apart, spreading it out more. Not too much there. And if I start squishing that together all the way, not too much. So marker 1 is really down, marker 2 came up. So and we really have a nice passband right here on let's go over and see what frequency that is. Where are we? There. So that is, so right there's a peak at 1, then it drops down to 4. Okay, it's not quite as flat as it looks on this here. Although yeah, there's flat again at 155. So it's kind of promising. It's like, oh man, can we get that? Can we get that marker, that band down into our 2 meter? So let's go ahead and turn that around again and attach the capacitor again. See if that makes any difference. Okay, so I'm flipped. I take the 22 picofarad capacitor again and put it on the radio side where we have the double capacitor on it. So now it's on, now it's off. I don't see as much of a change here as we did on the other circuit. That is really interesting. It's on, off. How about over here? Yeah. Problems. It's on. So right now I'm doing it on the antenna side where the 2 capacitors are. Now we take it off. Definitely don't see it as much here. Interesting. Should we just go ahead and jump a little bit higher? So that was the 22 picofarad. How about we use 68 just to have some big difference. It probably way too much, huh? Could also mean that we have to go smaller. Not totally sure here yet what we are seeing. So now it's on, I think, and off. Oh, so that's kind of bad. What happened here? It is quite sensitive. So now it's on. So the 680 is too much. Sorry, 68 picofarad. Go back to the 10 picofarad and see what that does. So let's put the 10 picofarad on the radio side. The number 2 came up, didn't it? So that might have been better. So let's look at the 2. So right now it's 5.5 or more. If you hold that guy on there, it's so hard. 2 definitely improved there. And so I think that circuit might work, but I need capacitors that I actually can adjust. So I think we have to go back to this drawing board and build one with adjustable capacitors in there and have some fun. The question is, do I have any decent capacitors that I can use for that? Can we just use really cheap capacitors, or do we need to use better quality capacitors on there? Gonna be hard. But I'm gonna wrap up this video for so far and have a follow-up video on my build with variable capacitors. That I'm really stoked now on doing that. So see you next time on my messy workbench.